commencing code walkthrough video. So initially I'd like to quickly address a couple minor changes that have been made to my code since a code walkthrough video has been created. So initially I've moved this line of code here, if hasQuit is true, exit, to right after when I run start game, because before it was later on, and if you were to quit during the start screens, then it would return an error because it would be trying to access choices here, which didn't exist, didn't have indexes. So that was that as an error. And also within that start screens for the has quit, I did need to specifically, before I was just like returning false, to actually get the has quit that has been set in a given run. So if I do, so it's initially false on a certain run of run screen, and then if I click the quit button, set it to true, return it, and then store it in this, which I return to here, and then I can get that back up to the top of the stack. So yeah, and then that will just get the has quit back instead of returning false, just so it, quitting works properly. And in position evaluator, initially in evaluate position, I had an algorithm here which would check to see if the last move was a capture, and if the square, and if the capturing piece is of a greater value than the piece that's being captured, and that square is being defended by another enemy piece, then assume that piece is lost, because it wasn't computationally feasible to do a full quiescence search, which is just playing out all of the captures on that square of all of the defending and capturing pieces. And while that did improve depth 1 gameplay, it proved to cause some weirder moves. I think the playing strength was better without that addition, so I have chosen to remove it. Also, in the AI, so it's here, yes. So if there's multiple different checkmate sequences that it has seen, then I've made sure to prioritize the quicker checkmate, because then, for instance, say it's got a checkmate in 1, but it's also got like a checkmate in 3. It might choose the checkmate in 3 because maybe it, I mean, they'd have the same score, but it might choose the checkmate in 3. And if it were to do that, it might just keep choosing a longer checkmate and never actually do the checkmate. You need to make sure it's the quickest one. So what I do here is I just have a list of checkmate indexes, and then if it's a checkmate, add it to the list. So I've got a list of all of the possible checkmates for a given for the AI's color, and then I just loop through that list, get what the path is, which is just a sequence of moves that it's seen, and I just find the shortest possible length checkmate and take that one to make sure it chooses the shortest checkmate as the best move. Okay. And also in create boards, which is in initialize board here. So when creating, because previously I was looping through the full board state at the very start of the game to get all of the piece images, and then using those piece images for instance for promoting a pawn, so I can have all of those all of the different pieces that I can promote that pawn to as images. But if I start from a different fen position, that's no longer a possibility, which wasn't accounted for before. So yeah, now I essentially make sure that it does run with creating that other board, like the proper initial board state first, get all the piece images from there, and then create it with the actual starting state. So you can see that that logic here in the user interface get images. So if there was a start state that's not the initial normal one, I just loop through the board, delete the pieces, create a normal board, and then I loop through the normal board to get all of the piece images, regardless of, because now that's been set here. So I'll just do that for all of them, and then I'll re-delete that and create the actual starting state. So then it's got all the piece images it needs. Because like for instance, if you're starting in a position where it's just like king versus king and pawn, that pawn isn't going to have the piece images that it needs to promote itself. Another change I did, make the move list here a stack, because I thought it was a much better structure to be using than a list in this case, because I didn't need all of the different list operations, and you only really needed push, pop, get a stack, copy. So it was a better choice. But yeah, so I have now implemented that as a stack, and I use those methods here with push and pop, and also in pawn promotion, which is in Move Manager here. I think initially I was defaulting to a queen for the piece type promoting, but now I just pass in 2 promotes. So I've got 4 different moves now for just for promoting the pawn to each different piece type, which was queen, rook, knight, and bishop. So yeah, I just in my move management, when I generate that, I then set that here. So that will be when I'm generating all of the possible moves in the position, which is right here. I just append each different class of piece that I want to check for, and I figured this was, and while it would be extremely niche case for not promoting to a queen, and unlikely to ever be played with this, because within the depth that I have decided to go for, it just wouldn't be, it wouldn't ever play that move. It would need a higher depth to be able to see that. But I have made sure, just in case, that is something that it does account for. And those are all of the little changes that I have made. The rest of the video will be as normal. I'll be doing my code walkthrough for my chess NEA. So it starts in the chess.py file. So I'll initially do the imports for all of the various classes I'll need. I import Pygame, initialize it here. I import pstats and cprofile for some time profiling to make sure, or to work out what the time bottlenecks are in the AI file. So I'll begin in the main procedure. So first of all, I load up the start screens and initialize them, and then I'll run start game, which is what loads the start screens, and I'll get the choices of the player as to whether they've clicked X and left the game, their choices as to like whether they click a white pawn, black pawn, AI or not, and what difficulty, and then the screen that I create in this method. I'll get and then this is me just getting all the choices of the player, and getting the color of the player one, and then the opponent is just the other color, so I set it to that. And then here I essentially initialize the board, which is just creating the initial board, like filling it with none at the start, and it creates a lot of the objects that I'll need later on, which I retrieve here. This, if you pass it, if you don't put an argument in here, then it will just create the board as it is normally in the initial board state. But here I'm passing in this fen string to essentially be able to for testing, so I can load up specific positions. And then here I'm loading all the images, the button images, the piece images, and so on. And then I'm drawing the board. So if you are playing against an AI and you chose to play as black, then you need to draw it in the orientation of black at the bottom, because obviously it doesn't need to be in the orientation of the AI at any point. And then if you're not playing in AI, it's always going to be in white's orientation, so you'll draw it like that, and then you'll update the display after you've drawn the board. Then you'll create the position evaluator object, which I'll need for the AI. And yes, then I'll create the player object, create either an AI or a player object as the opponent, depending on what the choice was, and then I can create the play game object. And then, of course, if they've clicked X at any point, we'll just leave the program at this point. And then we'll begin the while loop for the game. While the game has not ended, while it's not a checkmate, draw, or has resigned, then we'll begin the game loop, where we'll just play all of the moves for each player until the end of the game. And then after that while loop, when one of these conditions is, while it's now like checkmate or draw, has resigned, then if you know that the current color is white, then well that's the color that's lost. So this then when a color is black, so it's just the opposite of what current color is. And then at this point the game's finished, so we'll get the full move list that we've created throughout the game, and create the chess move notation for that list, retrieve it here, and then run the create the end screen object and run the end screens to see if they want to save to a file the final board state and move list printed out. And if they do, then there'll be that move list created that can then be saved to a file, which will be the current date and time as the name. And then this here is just ensuring that when it's that if it runs when it's not imported, but it is like specifically ran the main program. Yes, and that will be the main chess file. And then if you move on to the AI file, I'm importing all of the files I will need here. Yes, so in the AI object, I'll need all of these different objects for checking the game state, evaluating. These will all be necessary, and then node count here is for the purposes of testing, so I can see that the effects of alpha beta, whether it's reducing the number of nodes that you visit, and also if the MVV LVA is improving the how effective the alpha beta pruning is. So move in minimax, essentially just running a specific move within the minimax algorithm. So here, if we move in, where we add one to the node count, because if I'm doing a move in Minimax, then it's a node, so add one. And then if so move 2, move 3, that's just the square it's moving to. So if there's a piece there, then you know you're capturing that piece. So I just set it here because I will need to undo the move later, so I'll need to know that. Otherwise, it's none. So I'll then convert this specific move into the notation, just because currently it'll just be the number for the ranks and files from 0 to 7, and I need to put it into chess notation so I can create the best path for the AI that it chooses, so I can clearly see what it's doing and what's going on behind the scenes. And then this is just me creating that full move. So that would be like say it's C2 to C4. That was the move. Then that move is just going to be saved as C2 C4, and that will be in that will be added to the path. And so here this is just getting all of the castling and en passant moves that are possible in a position, because I then need to add two board states, because for draw by threefold repetition it needs to be greater than or equal to 3 times that the board state has occurred with the exact same castling and en passant moves possible in the board, because obviously you could have the exact same board but not the same castling and en passant rights, and that would not count for another board state. So yes, I do need to know that. I just add that on to the end of the board state. So add that in. I get the move counter, because then you need that to know that for draw by 50 move rule, draw by 75 move rule. I'll need to undo that and increment to it, undo changes and make changes. And then yes, this is me just removing that capture piece from the list, just deleting it. And then here, if it's a pawn move or if it's a capture, then you reset the counter, because that's the condition for 50 and 75 move rule. Otherwise, you just increase it by 1. Because 50-75 move rule is like per player, so it's 100 and 150 in total turns. So here, if it's a king and if it's a castling move, so it's just moving 2 files in either direction, then this is just handling the rook movement separately, because castling is the only move that moves 2 pieces, so I thought it was better to handle that logic separately. So this will handle that logic. Here, this handles the pawn promotion logic, so if within this, it will just check if it is a pawn promotion, and if it is, it will then update the board, play that move. If it's a player, then give them the prompt for what they want to promote to. If it's the AI, it just goes for queen. And then en passant move, so that will just see if it's possible. And then that will need to be handled separately as well, because it's the only capture where the capturing piece doesn't move to the square of the piece that it's capturing. It moves like one above it or below it. But yes, and then if it hasn't, if neither of those things were the case, because we update the board in those, so it's just a regular move, then play that move, update the piece's location for that, and set the last move as that, because I do need to know the last move for things like en passant. But yeah, it's not necessary to do a full move list, which I'd need to then add if it's like a check or something, because there's no point doing that, and it would just take a lot longer. So if it's then if it's a king or if it's a rook, then you need to obviously set that it has moved, which is then needed for castling, because if the king's moved, you can't castle, or if the rook that the king is trying to castle with has moved, then you can't castle. So yeah, if it's being moved, then you set it to true and get what it was before, so you can set it back to whatever it was once you undo the move. And then here, I'm going to run the minimax algorithm for the opposite for the opposite player, returning the score and the path, and then yeah, that will just run for the opposite of whatever the maximizer currently is, and that will be at one less depth because it's the other is like you've just played the move, so it would be one less depth. Um, and then once you return from that call, it will then reset the move counter back to what it was. This will move the rook. If it was a castling move, will move the rooks back to where they were. And if it was a castling move, then it was previously false for has moved, so I just set it back to false. And then you move the rook back to where it was, and then I run this undo moves method, which will handle that logic, and I'll move the piece back to where it was. And then if it's a king or rook, set it back to what it was before. That has moved, and then we remove that last added board state from the board state list, and then I return the score and the path back to what called move in minimax. And now if we move on to the onto the minimax algorithm, so initially we'll just see if it's a checkmate, if it's a draw, see if the game is ended, and if it's a depth of 0, because obviously I can't search to a terminal game state. With chess, because of how large the game tree gets, so I'll then evaluate the position, get the score, and return it along with the path, like that what you're going to add to it, which is nothing because it's ended. So then I'll get all of the valid moves here, but then they're not all fully legal. I don't see if it's a move that would put my king in check or anything, because that would massively make it less efficient, because I might end up pruning those nodes. So it's not necessary. And then, so if it's a maximizer, then I'll set the minimum best score as negative infinity, because I'm going to be comparing to it and make sure I can do better than that. And then otherwise it is infinity, which I'm then trying to get less than. Yes. So I'm essentially looping through the moves here, and here once I'm actually on the move, I will need to validate it. So valid in check move is essentially just playing the move and seeing if it results in a check on my king, and if it doesn't, then it's legal, it's valid. But yeah, if it's not valid, then move on to the next move. Otherwise, this is the move, and then I run move in minimax to handle the playing the move logic. And then I can move on to the next move. And then yes, so if it is the maximizer, then if score is greater than the minimum best score, so if I've got a move that's better than a move I previously found, then I update it. And then here I'm just converting the move notation into chess notation, so I can update the best path, essentially. Just adding that on to what it was previously, what I returned here from move in minimax. And then if score is greater than or equal to alpha and running alpha beta is true, then because you know that the best possible move will have a score greater than or equal to alpha, so you update alpha with score here, And for running alpha beta is true, that is so I can enable and disable alpha beta fairly easily, so I can compare the nodes explored to ensure it is proving effective. So I can update alpha there. And then it's the same logic with the minimizer, except I'm comparing to the maximum best score. If it's less than it, then I update, and then yeah, this will be the minimizer best current score that you can achieve. So you update that, and then this bit here is the actual pruning of the nodes. So if and obviously you don't do this if you're not running alpha beta, you don't want to prune. So yeah, if beta is less than or equal to alpha, then you know that the current best option is essentially worse than like a branch you've previously visited, so you can just prune it essentially. Like the current best score that the minimizer can get is then less than or equal to the best score that the maximizer can get. So there's no point at looking at that at the remaining moves at that node, because it's never going to go down that branch because there's a better option. So yeah, and then here I'll just return the scores and the best path. So then here, similar logic to before, just getting the castling and opposite moves, adding to board states. If it's checkmate, you don't want to be playing a move, you just leave the method. Same with draw. And then yes, this will be just setting, because black is the minimizer and white is the maximizer. And this is just outputting what the depth is, making sure I know what's going on behind the scenes. Here we get all of the valid moves, or the pseudo legal moves at least. And this is where I set whether I'm running alpha beta or not. So similar logic to before, just validating the move, playing it, and then the different part here is adding the score, so I can see what move corresponds to what score, and then what the best path is for that down that branch, and then move on to the next one. Yes, so it's so here I'm just going to then find the score that is best, so that the maximum best score infinity, minimum best score negative infinity, because I'm then trying to find better than that, and then the best index is the index of the move that is best. And then yeah, so I'm looping through the scores list here, and then if I'm the maximizer, then I'm trying to find the maximum possible score. If I'm comparing index 4, which is the score here, and then I'm updating that and updating what the best index is, and similar logic here for the minimizer, getting that best index, getting the best move here, and then yes, this is the best path, which I can then output here and along with the nodes visited, and then you have to reset it to 0 obviously, because then it will continue to sum the nodes in future moves. So yes, that's the initial piece, and this here is essentially just setting. So then the purpose of the set previous best move score is essentially, so I know what the score of the last played best move was that was evaluated by the AI, because then I know whether essentially if the player clicks draw on their turn, I then know what the last move score that the AI evaluated was, so I can know whether the AI will choose to draw or not. Because if the AI is winning, then it won't draw, but if it's losing, then it will choose to draw. And then here, this is getting all of the other piece moves, because for creating the chess move notation, I need to know all the other piece of the same type that could move to the same square, so I can uniquely specify the initial piece. This is just setting the captured piece, whether it's a capture or not, which is the square that the piece moves to. And you remove the captured piece from the list. You handle the moving rook logic, and then if it's a pawn move or if it was a capture, reset the move counter or increment it. Update the has moved if it's a king or a rook. And then this is handling en passant, if it's deleting the pawn. And then setting the capture here, running the pawn promotion logic. And now here, if it was either a pawn promotion or en passant, then I have to see if it's a check in the position, because I need to be able to add to the move list the move with is check, so I can add the plus onto the move. If it was a pawn promotion, and if it's en passant, then you know it's a capture, so I can just put in true here. Yes, and then if it's current color white, then I'll flip who's playing is the other person's turn, so draw the board in their orientation. And then you can leave this method. Otherwise, if it wasn't pawn promotion or en passant, then play the move, update where the piece was, see if it's a check, and similarly add to a move list, update the last move, and then play the move, update the user interface, and then leave the AI file. Onto the bishop file. So now onto the bishop file. So first of all, we run the parent because it's inheriting from the abstract class piece. So we run the parent's init. We'll define its notation, the value of 330, and then the piece square table, which are all of the values for the bishop squares to be on. And then the black piece square table is just a flipped version of that. And then get valid moves here, so I'm just running the get possible moves, get bishop queen movement here, and just returning that, and just the getters for both of those variables. Now onto this. So here I'm passing in the board, and because I will have already created it, and I'm setting the piece storage. These are all the piece lists, so that I can just easily access a specific list, like easily get the location of the king without having to search through the whole board. And then this is the board states list, so I can do draw by threefold. Make piece is just setting the location of the piece and updating it on the board. Getting the board states here, adding to board states. So this is just current position, looping through the boards, adding on each item onto that string, adding on all the possible en passant moves and castling moves, and what player it is to move, and then adding that on, because all of those things must be unique for draw by threefold. And then removing board states, just popping from the end. Set board is just it's setting the board equal to that. And deleting the piece, it's deleting the piece. It's setting it to none and deleting it. So getting the board is that. Updating the board, so that's just moving the piece at the initial square to the final square and setting the initial square to none. And then flipping the board, so we reverse the rows, and then for all those rows we then reverse the columns. This is only used for like flipping the board when I show that on user interface. For the sake of efficiency, it's best to just code it assuming white, assuming the same orientation of the board, because flipping the board is a very time-consuming process. So getting the list is just getting the specific piece list from my piece storage dictionary. This is adding that to the list, getting the notation, accessing the element, and adding it in. Then moving from the list, I'm accessing the piece list, and I'm essentially just saying if I'm just going through that piece list until I find a specific object that I need to delete, and then once I find it, I remove it, and I can stop looping through. Check square attacked, so this is useful to see if it's a check, and also for I use it in my position evaluator to see if a capture is being defended by other pieces. So and because of that multi-functionality, it's mainly used for seeing if it's a check, but I only do this to get the king's location if I need it. And then this is just going through the ranks and files of the square, to essentially see if any pieces that can attack along ranks and files are there. Yes, and then if any of that is true, then the square is attacked. And then here we go through knights, we go through all of the offsets, because we go through +2 or -2, or just L shapes, so 2 along, 1 up, or 1 along and 2 down. So this logic here is essentially going through 1, -1, 2, -2, so that would just be offsetting the rank by 1, -1, and then for that you'd be offsetting the file by 2 or -2, and then do it the other way around as well, which is what this logic is doing essentially. You do it by you loop through both matrices, and then you just add the offset to the rank and the other offset to the file. So for every rank offset by 1, you do file offsets by 2, -2, and for every rank offset by -1, file offsets for 2, -2, and then for every rank offset by 2, you do file offset 1, -1, and rank offset by -2, you do file offset by 1, -1. So that's what this code block here is essentially just doing. Just reversing with it, this if statement is just doing the second one for the rank, for the rank offsets by 2 and -2. Yeah, and that would just be going through all of the L shapes that they can move to, and I'll only be outputting check if you've actually played the move, because I would run it from like the minimax algorithm as well, and you wouldn't want to be outputting check every time you do that, especially because it may not be necessarily be run for checks. And then here, this is specifically looking for pawns. So if you need to separate white and black, because if it's a white pawn attacking, then it'll have you'll be looking at different rank offsets essentially, because it's always oriented in white with white at the end. So yeah, essentially, if you're looking for a white pawn that's attacking a square, you'd be looking at essentially rank -1 for white attacking that square. So then, yeah, if either of those are true, then leave and return true for attacking the square. And And then I look along the diagonals, which bishops and queens can attack along, and similar kind of logic here, return true if it does attack any of them. And then here we're just looking at attack from, and then seeing if there's a king there, and that it is an enemy piece. So if it's an enemy king that is on any squares that a king would be able to move to that square to attack it, then it attacks the square. And then moving on to this file, so we've got the full move list, and then the notation list, and whether it's checkmate or not. So yeah, this method is specifically for just converting the 0 to 7 ranks and files to the actual ranks and files that are used in chess, so A to H for the files, and ranks 1 to 8. So I've just got constants for that I import for the file letters, ranks, and files that I then return. So this here we're creating the chess move notation. We loop through the move list, get the current move, get what get all of the information about this specific move here, and any other pieces of the same type that can move to the same square. I then convert the initial rank initial file, etc., to the notation of the squares that they are. So this is, if it's a kingside castling move, then that will be the notation. Queenside castling, that will be the notation. Otherwise, if it's not a pawn, then you add on the notation, because pawns you don't add on the piece notation. And then yeah, so if there are other pieces of the same type that can move to the same square, then you'd loop through those moves and you see if the rank is the same, then you know it's the rank is not unique, file's the same, file's not unique. And then you just add what you need to uniquely specify the piece that will move there. So for instance, you could have several other different pieces that could also move to the same square. So obviously in rare cases you can also be adding on the entire initial square here if you need to uniquely specify it. So yes, if it's a capture, then well, if it's a specific pawn capture, you need the initial file. That's the convention, and then you want to add on X for capture. Yeah, and then you'll add what the final square is right at the end. And then if it's a checkmate, add the hashtag. If it's a check, add the plus, and then add that current move on to the end. Continues looping through, and that's your list. And then there's a getter here for the chess move notation. This is a constants file, just all of the useful constants that I'll need throughout my code. This is the end screen file. So just defining some different fonts here, that different sizes that I use for different text on these screens. Okay, and then here, this is me just immediately getting the winner and loser color, not in terms of B and W, but just black and white. So I can easily say that in it when I'm drawing text to the screen, just put winner color. So yes, so I've gone for grey here. I say it's game over, and then I draw the end game state here to the screen, and whether it's a draw and has resigned. And then we've got the prompt here for asking if they want to save to a text file, and essentially load and scale and blit to the screen, and set up the collide point X and Y's here, so I can click the buttons, and yeah, so you just load on those buttons, update the display, and then you start looping for the user input for every event. If it's quit, then stop running. Assume it's no button click, essentially don't want to save to a file, and just leave. Then if it's a click, get the location, and if it was clicking on the yes button, then I essentially here I just get the current date and time formatted in this manner that I can then add on to the end of the file name, so I can uniquely say that this game at this time on this day, this corresponds to this game, and then you'll be able to sort by date played. Yeah, so then that's the file path, and here I open up in write mode, and I loop through the board. So this is just me adding in the board outputted to the file. So I do dashes for the empty spaces, and then str of piece, which is just the notation, and then a space. And then yes, I write that line, and then get a new line after the board for the text here that shows the end of the game. They get a new line for the move list. So then here I just loop through the move list and count and what the move is here. And then this is needed for the correct number for each move, because it's because move 1 is then like a turn of the first player and then the other player. That's move 1. So by doing modulo by 2 here and adding 1 onto the count like that. But yeah, but by specifically adding on the count here only when index plus 1 mod 2 is 0, I ensure that it only changes when it needs to. Like on the first move, it's just count of 1 for the turn and the opponent's turn, and then it's onto 2. So here, fill it with grey, and then display a saved successfully screen. Update the display, and then just have a little delay so the user can see the screen before it closes down. And then I do a similar thing for when the game ends, so you can see how the game ended. So and if you click the no button, I just leave the method, and then this is just a draw text helper method, creating a font object, and then just splitting it to the screen. And then this is the method for getting the actual color from the character. So this file here is the game state class. I get all the objects that I need. I've got a threefold repetition variable here, so I can see if it's possible to draw it by this method. And then this here is just checking for essentially. So essentially used for checking for the draw method to see if so it's like when I'm checking what the it's checking for the game state. So essentially seeing if they have any other pieces, because you need to check certain conditions for the draw method. So here I'm just returning here because there's no point doing that logic if they're already true. And then you just go through the piece list, and yeah, if it's white other pieces is true, otherwise black other pieces is true. So here check game state. This is needed because the king piece square table, there's two, mid game, end game, because the end game it's more favourable to move towards the centre, so it needs to change. So you need to be able to identify when it's mid game versus end game. So here you get the queen list, and if there's no queens, then we just go for end game. Otherwise, there's between 1 and 2 queens. So I figured if there's 3 or more queens, then you definitely don't want to be thinking it's an end game. It would be unsafe for the king. to be in the center, so I return mid-game there. But if there's between 1 and 2 queens here, then I essentially need to check to see that every side with a queen has no other pieces for it to be an endgame. So I initially set those values as false. I loop through the queen list, and I essentially get what colours have a queen, essentially. So I get all the respective lists here, and then I check to see if they have any of these other pieces, either white or blacks. And then if white has a queen and white has other pieces, then it's a mid game. Otherwise, if black has a queen and black has other pieces, it's a mid game. Otherwise, it's an end game. And then this is my is checkmate here, so I've just got a moves list, set it to false. I see if it's a check, and then if it is a check, I initially set is checkmate true here, and so yeah, I've set is checkmate true here. I loop through the board, and then if there's a piece there, and it's a piece of the side that we're checking to see if it's checkmate for, I get the valid moves of that piece, and then I loop through them, and if any of them are valid moves that don't put their own king in check, then it's not a checkmate, and I just keep going through all those moves until and then if I never return false, then it's true, so leave, return is checkmate. And then is draw, so is draw, essentially setting has pawns false, stalemate true, black pieces list, white pieces list, and these are all the draw by insufficient material cases here. Getting the move counter, so if it's greater than or equal to 150, this is a forced draw, so that's automatic draw. Otherwise, for the 75, you'll need to specifically, or otherwise for the 50 move rule, which would be move counter greater than or equal to 100. That's handled when you click the draw button in user interface. So yeah, you loop through the board here, and if there's a piece there, and if it's a pawn, has pawns is true, so it's not insufficient material. So there's no point running the rest of the logic for that. But if it's possible, then you know if the length, if black or white has greater than or equal to 3 pieces, then it can't be a draw by insufficient material, because all of those cases have between one or 2 pieces for each side. Otherwise, I just append to the white pieces and black pieces lists. Yeah, and then I'll get the valid moves of a piece, and essentially here I'm trying to detect if it's a stalemate. So if it's by default is stalemate, it's true here, and I loop through the moves, and if it's a valid move, then it can't be a stalemate. So I set that to false, and running loop is false, so I can leave that while loop, and I don't need to run that loop again throughout the board, because there's no point. And then if I've left here and is stalemate is still true, then it's a stalemate. So leave, it's a draw, and then you need has pawns to be false here, and it's still possible to be insufficient material. Then I get the black and white drawstrings. I create them from the black and white pieces lists, and then if both players have one of these cases here, then it's a draw. And then here I'm getting the board states list, getting the last one, and then I'm looping through. I'm counting all of the board states that equal to that position, and then if it's greater than 3, then it's possible threefold. So I set that to true, and then if that's no longer true, set it back to false. So then if anyone clicks draw in this time where it's set to true, then you can draw. It's an automatic draw. This is just a getter for threefold repetition, and then this is valid in check move. So if there's a piece you're capturing, you need to know that so you can undo the move. And if it's a king you're trying to capture, that's obviously not a legal move, so you leave at this point. And yeah, so that's the initial piece. Delete the captured piece. Yeah, so then you run the pawn promotion and on Persona logic for playing those moves if applicable. And then yeah, if it's not either of those cases, then you play the move, update the piece's location, you see if it's a check, and then you undo the move, reset the location, and then if it's not a check, then it's a valid in check move, so true, otherwise false. We're essentially just playing the move, seeing if it's a check, because obviously if you make a move and after playing it puts your own king in check, it's illegal. So yes, and then here look for pawn attacking is just specifically handling that earlier logic in the draw. Oh no, sorry, in the square attacked, to see if pawns are attacking that square. So if it's within bounds and it's a pawn and it's an enemy, then it's attacking. So yeah, and then get possible moves. So getting the board, getting the appropriate objects. So here we're just searching through the rank and file for the square attacked. So I'm setting the initial offsets, which I pass in here, and then essentially while I'm searching through this specific direction, I'm checking within valid bounds, or if there's a piece there, then you need to stop searching that direction because you can't move over pieces. But you might be able to capture that piece, so you stop there and then you check that later. Otherwise, yes, keep searching further down that vertical or horizontal, and then yeah, if you've reached a piece here and it's within bounds and it's an enemy, then you might be able to capture that, or that you're attacking that square, essentially, and then otherwise it's not. And then here this is getting the diagonals. So essentially here, this method here searches through the rank and file of a specific square for any pieces that can attack down there. So I get the initial offsets, I search the direction, go for a loop here, and if it's within bounds and there's a piece there, you stop searching the direction because you can't look over pieces, you can't jump over them. So yeah, otherwise I keep searching along there, and then if there's an enemy piece here, then essentially it's attacking that square. So you can return true, otherwise you can return false. And then here, getting the diagonals. So I'm looping through the different offsets from -1 to 1 inclusive, and while it's not itself, so that's just getting all the different diagonals. You can go down the 4 different, and then I just loop down each specific diagonal. And then here I'm getting the specific offset, because this is logic I use multiple times. So here I'm getting the offsets, and then while within its valid bounds, and there's not a piece there, then you can keep adding on to that offset until you reach it's not in bounds, or there's a piece there. And if it's an enemy, then essentially it's a square attack. You return true, otherwise you return false. And here, get rook queen movement. This is just searching the different or the rank and file left and right, above and below the rank and file. And here this is searching a given direction. So as I'm searching along this rank offset and file offset, so if there's a piece there, stop searching, because you can't attack over a piece, and then otherwise I add the move on because it's an empty square that I can move to and keep searching through. And if there's an enemy piece there, then it's a capture that you can add, so you add that move on. Bishop queen movement here, I'm looking through the different offsets, and while it's not its own square, I check that given diagonal for bishops and queens. This is checking a specific diagonal, getting those offsets while it's within bounds and there's not a piece there. I add on all of the moves here, add on the offsets, and then if there's an enemy piece there, it's add on the capture. So here, initialize boards, add in all the files I need. So initially I create the board, 2D list here with none, 8x8. Create all of the objects I'll need for the rest of the game, getters for all those objects I'll need. Initialize piece, this is just creating a specific piece and giving it all of the objects it will need and the rank and file for where it will be created. And then make piece, just setting the piece object to that location. Get the board, and then this is initialize the top and bottom ranks. So essentially here it's just quicker to do it this way. If I pass in a specific rank already here, then I can just use it to map to what color it will be, because I'm doing it white at the bottom, so white would be at the row of 7, and then black is at 0, so that I initialize all of those pieces for the bottom and top ranks. Now this method here is for starting from an alternative start board position, mainly for testing purposes, so I can see how my AI behaves under different set board states. So yes, here I pass in the starting state, which is a fen string. So essentially looping through. So yeah, all of these notations are used in this string. So I'm just mapping to what the class is, and this is an example of what I'll be converting. So I'm looping through this starting state, and if it's a slash, move on to the next row, reset the column to 0 because it's at 0, and move on to the next item in the string. And if it's a number, then that's the number of spaces. So you want to move on by that much. And then here, if it's the other case is it's a piece to create. So I pass in here for piece mappings the lowercase of the item to get what object it is, and then I create that given object at that location. And then I set the board here. So then this is create board. By default, it's no input here for just regular board state. So yep, as normal, we'll loop through the board here. And then if the rank is 1, we just initialize all of the pawns as black, and then for 6 it's white. So I'll create the bottom and top ranks, and then set the board equal to what it is now. And then this is a helper class for a lot of the logic. So checking to see if there's a piece there. So if it's not none, then there's a piece there. Enemy piece is if there's a piece there and it's a colour different to the turn of the player who it is currently, then it's an enemy. Otherwise, if it's equal, it's friendly. And then check-in bounds is just a valid coordinate. And then here we have the king, so that's its notation, arbitrary large value, because it's the king, you can't lose that. So you have the has moved here because you need to know that for castling rights. So you've got different mid-game and end-game p-square tables for the king, favouring the centre more later on in the game. And you flip those for black for the mid-game and end-game. Get all the respective objects that you need. Add itself to the respective piece list. So here I'm getting the valid moves of the king. So I'm essentially looping through all the squares around it, apart from itself, and while it's within valid bounds. And if there's not a friendly piece there, then it's obviously then it's an enemy. Then that's a move I can play. And then here you need to say if the current colour is equal to itself, because then otherwise you'd be looking for castling moves of your king, and then you'd be seeing if the enemy has any valid moves to like attack the squares the king is castling over, which would then check the king, which would then check its castling moves, which is just like a recursor. So you need this step here. Yes, so then you check both king side and queen side direction, and then you return the moves. So getting and setting for the has moved to be able to like do and undo moves here, and then this is just getting the white p-square tables, so getting the current game state because you need to know whether it's mid-game or end-game, for whether you want the mid-game one or the end-game PST. Same logic for black, and then so this is castling here. So you see if it's a check, because if it's check, then you can't castle. So these are all the squares, target squares the king will be castling over, so you need to make sure no pieces are attacking it. So if it's king side, you get what essentially where the rooks would be moving from and to here, and queen side same. So yeah, if it's not a rook where it should be for castling to be in this direction to be a possible move, like if it's white for king side castling, then there needs to be a rook at 7/7. So if this isn't a rook or it's moved already, then can't castle. So return moves. If it hasn't moved and it's not a check, then you can start looking at the logic here. So if it's if it's king side, then you're just looping over those squares and making sure there's no pieces on them, and adding on those to the target squares that the king is castling over. And it's same logic for here for queen side, just looking for the columns -1. So here I'm looping through the board, and then yeah, if there's a piece there, getting its color. If it's an enemy piece, then yeah. So if it's a pawn, I'm setting the appropriate offsets, and then yeah, and then if that's in target squares, then return moves, because then the pawn is attacking the target squares, which makes castling illegal. Otherwise, I get the valid moves of the piece, and I see if a piece has valid move onto those target squares, which is an enemy, then castling's illegal. Return moves. So here, it's king side. I just add on those moves, which it is, and that's where the king moves to, and then -2 here, and return moves. And then for the knight, same piece square table, value 320 notation, add itself to the list. So get valid moves here. Got the matrices here. I have already gone through this knight logic in the check square attacked, for it is similar here. And then this is getters for the piece square tables. And then this is just manage players files, so just getting the colors of each opponent of each player, handling that just within that class. So this is the move management class. So we get the board, get the last move, because for a lot of purposes I only need to know the last move, so I don't need to handle the move list logic, adding and removing in Minimax and such. I need to know the last move for en passant with pawns. But yes, so I've got some getters for all of those last moves, setting the last move, setting the best move score, increasing the move counter, getting, adding, removing, reset. So this is the pawn promotion method. So that's the initial piece. If it's a pawn and it's moving on to the final rank, depending on obviously the final rank is different depending on what your color is, and then if it's not an AI, then I need to run the pawn promotion prompt to get what the player clicks on for which button. Otherwise, you default to a queen for AI, because with the limited depth that I'll be able to reach within, to make this project able to be achieved in a feasible amount of time, it would be at these depths that I'd be able to reach, which is about up to 4. There, it's extreme. There wouldn't really be any lines for promoting to for under promoting here as being a better move that the AI will see, and it would just add on a lot of time complexity for the AI needing to do all of those different moves. And then here I'm essentially deleting the initial pawn, moving it from its list, and then creating the specified promoted piece, and then making it on the board, and then and then here is just setting the last move, if it wasn't ran from valid in check move, because so here you only need to run this logic here if it wasn't run from valid in check move, because if it was then you don't need to run the logic, because you just need to undo it. You need to know what the accurate last move was. It's just not necessary to be setting it there. And then on % move here. So if it's a pawn and I'm moving to a different file, but I'm moving to an empty square, then you know it must be an on% move. So then I'm setting where the pawn is. So if I'm playing as white, then that will be where it is at rank +1, and I delete that piece. Otherwise it's at -1 and delete that piece. And then I move the pawn to its final location. And then I'm updating the last move here if valid check move is false. I'm setting the location of that piece there, and deleting the pawn that was captured and returning it, because I may need to undo the move later. Otherwise, just return none. And this get castle rook movement here is essentially just getting where the rooks will be and where they will move to in a castling event. So if it's white, it would be at 7-7, moving to 7-5 if it's kingside, and so on. Then otherwise it's just not a castling move. So yes, and then move rook castle here. So if it's a king trying to move, then I get the movement of the rooks. And then if it's -1, not a castling move, so leave this method. Otherwise, that's the rook. And then if it's not a rook, or if it's moved already, then you can't castle, so return there. Update the location of the rook, set has moved to true, move the rook here, and return. And this is the captures ordering by MVVLVA here. So essentially, I loop through the captures list, and I find the maximum piece value for what's being captured, right? So I'm finding the maximum victim value, and then I'm looping through the captures, and then for every instance where the captured piece is equal to that maximum value, then I add to a different list that capture with that max value, because then that will now be sorted by most valuable victim. And then I pop from the captures that particular capture, and then I can continue this process, finding all the maximum values and adding them in until I have a list that's just will be sorted by most valuable victim. And then you need to find least valuable attacker now, which is by a similar process. So if I loop through the captures list here, I get the victim value. I've got a separate list here, so I loop through the captures, and while it's equal to the specific victim value, because there might be multiple different attacking pieces for a specific victim value, I get the attacker value and I add it on here. So then I've got so now I just have a list with that attacker value, with all of the attacker values for a specific victim value, which I can then which is then reset here as I go through that full list. But yes, now I go through this list, I find so I loop through the attacker values, and then I find the lowest value, and then essentially so this is here is just handling on% logic for the direction or for the location of the piece that is being captured rather than where it moves to, because this is the time where it's different. Otherwise, I just add this capture to the sorted captures list because it is for the highest victim value, and I've found the lowest one, and then I pop that from the attacker values. I keep going through. I keep going through for the maximum victim value as I find all of the attackers for that, and I keep finding the least one each time, and then removing it and adding it to the sorted. So then I've got, and then once that's empty, then the process then repeats going through for the next victim value down. And then you'll have the end result will be a list sorted by the most valuable victim, least valuable attacker, move ordering algorithm. And this is the converts ranks. And yes, so here then we move on to the getting all of the valid moves, passing in what we need here. And then is initial AO move is false, because if it's true, I want to return the sorted captures list so I can see that the MVLVA algorithm is working for testing purposes. So yes, and these are all of the piece notations. So I go through all of the, and then for all of these pieces, I get their appropriate. I get the respective piece lists. I loop through each object, and then if it's equal to the turn of the player it is, I get its location, get its valid moves, and then yeah, if it's a capture and it's not a king, then add that to the captures lists, because you can't capture a king obviously. And then here, if it's moving to an empty square and it's a pawn and it's a different file, then it's en passant. Then you set you adjust the final rank to be the rank of the pawn that you're capturing, not where the attacking pawn moves to. So you handle that logic here. And then if it's not a king there, then you just add the move as you normally would. Yes, and then if you're doing move ordering, which you may not. Yes, here you loop through, and then while valid is false, you get the clicks at the play, you get the move. And then yeah, this is if it's a resign or a quit, -1, you leave. Similarly, if you accept a draw offer, then you leave as well. And then the piece that's the initial piece. And if it is a piece, then you get its valid moves. And then if it's not, if where the player is trying to move that piece to is not in the valid moves of that piece, or they're trying to move an enemy piece, or it's a move that puts their own king in check, then it is not legal. So you then so it's clear what squares you tried to move to, and for an accurate message as to why it's incorrect. Otherwise, then if it's a king, if it's a castling move, then you handle this logic to make sure it's valid. So if it's a rook where it should be, and if it hasn't moved already, and it's the color that it should be, then you can set valid to true. Otherwise, it's invalid. Yeah, and then if it's a king or if it's a rook, update its has moved status because you've just moved it in that method, and then return. Get other piece moves. This is getting the other pieces of the same type that can move to the same square for the moves list creation. So this is the if it's not a pawn, because it's not possible to have other piece moves that can move to the same square. For a pawn, you already add the initial file, so it's already unique. But yeah, so you get the piece type list. You loop through each item, and then if it's not the object that I already am trying to move, and it's of the correct color, I get its valid moves, and where it currently is, and if the rank and file of where it's trying to move to are the same as the rank and file that I tried to move to on my move, then if the move is valid, then it's a move that that another piece can play. So then I add in the initial rank, initial file, so I can uniquely specify it in chess move notation. And I've found that one essentially. So then I return here, and then get castling and some moves here. This is just getting the king list and pawn list, looping through the king list, getting the castling moves, getting the en passant moves, adding them on. Display notation lists. So essentially, we're just creating the chess move notation list here. We're just getting it and then outputting to the terminal window what the notation list is and the number of moves played by each player. So it's very easy to see with things like 75 move rule and 50 move rule, if that's possible. And then this is the undo moves method needed for like valid in check move and running the minimax algorithm. So if you've captured a piece, then you need to recreate that captured piece. If you promoted a pawn, then the piece you promoted to will be at final rank, final file. So you delete that piece, and then you recreate the initial pawn where it was before it made the promoting move, and make it here. And if it was en passant, move the pawn back, and then recreate the pawn where it should be at the correct rank offset. Add that to the list, and then if it's a regular move, then just move it back to where it was and recreate any captured pieces as necessary. And then if it's not ran from the minimax algorithm, then I remove from move list. I never add to move list to minimax because I don't need to, it's unnecessary, and I would need to run the is_check method, which would massively increase the time that minimax takes. Yes, and then if previous last move is none, then I set the or if it's not none, then I set the previous last move as that, because it's none in valid in check moves, so it's where you wouldn't need to be setting the last move. Yeah, and then this is the pawn file with its piece square table, and the black one and its rank and file. So this is getting the valid moves, setting the correct rank offset to be looking for the pawn move. So yeah, so I don't always need to necessarily check, or as in when I'm specifically getting en passant moves, then I don't need to run this code, so I just skip over that because it's unnecessary. And yeah, so I'm looping through. Well, no, I'm not. I'm getting if the rank plus the offset is within valid bounds, and there's not a piece there, then it's a move for one square. And then yeah, if there's an enemy piece at the file -1, add the rank plus the appropriate offset, because you've got to handle for black and white differently, because I'm not flipping the board. Yes, you add on those captures, and then if it's on its starting rank, then you know that essentially if that it can move 2 squares, and this is 2 times offset because it's moving 2 squares in that direction. But yeah, so it's can move 2 squares if there's not any pieces in both of those squares. It can move there. And if the move list is greater than or equal to 2, because you can't play on passant before that, you get what the last move is. And then if it's a pawn, and yeah, if it's on passant, then you essentially add that en passant move. Yeah, and if it's on its starting rank here, then you just see if it's moved off, because you can't move pawns backwards, so you don't need to know. It just needs to be on that rank for it to be on its starting rank, having not moved. And then getting the piece square tables. And then this is the piece abstract class that all of the piece children inherit from, using all of these different methods. It's a good blueprint for what a piece should have, and these abstract methods are what the pieces that inherit from it should provide an implementation for. So by getting all the appropriate values, piece colors, getting notation, location, etc. This is flipping the piece square table to get black's one, which is essentially just flipping the rows and then flipping the column there, and then adding that on. And then the str here is so I can easily for outputting, for getting the notations. This is what I do. You can do str of it, and it just will give me this. And then the player file. So these are all the objects that the player will need for this. So if it's player 1, I'll just be outputting player 1 move, otherwise player 2 move. So I'm getting the castling and en passant move because I need to know that for adding to board states. And then I'm getting the valid move for the player. And if either of these things here are true, then we leave, we don't play the move. So this is getting the initial piece, getting any other piece moves if applicable, resetting and increasing the move counters, all similar logic that I have explained. And yes, so if there's a piece where at the square that you're trying to move to, it's a capture. So yes, and we handle moving rook, en passant, and pawn promotion logic. So, and then I'm deleting the capture piece from its list. And then if it's just a regular move, not en passant or pawn promotion, then I update the board, I make the move, I update the last move, and then I see if it's a check, because I need to know that to add into the move list, to add the plus on. So I add that on here, I update the location of the piece, and I show the move on the user interface, and then I return here. So this is the play game file, passing in the appropriate objects I need, along with AI depth here that I can easily change. So game loop here, this will be the first move, so white's going first. So if player 1 is white, then I get player 1's move, and I display the notation list each time so I can see what's going on, and make sure it's all correct. Otherwise, if player 1's not white, then the opponent's white, so play their move, and then you add 1 to turns after this first move, so then it's the if player 1's white, they just went, so then it's the opponent's move, display that list, and then if it's not the end of the game, then I can just get the player 1's response to it, and then otherwise I just get the opposite of this, essentially just get the player 1's move, and then similar logic here, get the opponent's, and then if the game is ended at all here, I print that has happened and I return there. And this is the position evaluator file. So So I get the objects I need here. So evaluate piece squares. So I'm essentially looping through the board. If there's a piece there, then and it's equal to a current color, I'm getting its specific piece square table, and I'm just getting the value of that square, because there's a direct indice like mapping from the board to the piece square tables, because they're both 8 by 8 obviously. So then I add on the value onto the piece square count, return that as needed for the position evaluation, which is here. So if it's a checkmate, then current color is what loses. So if black loses, then that's a very high positive score. Otherwise negative, because you want the AI to always choose this one, so it should be definitely at the extreme. And then if it's a draw, it's just it's 0 regardless. So I get the last move here. I get the black and white score, which are both positive at this stage. It hasn't, because normally black scores favour more negative. That's handled here. So yes, and then if the last move was a capture, then I get the values of the initial and captured piece, and I see if that square that I just captured on was defended, and if it is defended, then I essentially assume that piece is lost, so I subtract that from the black and white score. And the reason why I'm doing that is because there's a bit of a horizon effect problem. So say you set at like depth 4, maybe the last move is like queen takes pawn or something. It doesn't know that at depth 5 that pawn's actually defended and it loses its queen, but it doesn't know that. So it might play a poor initial move following that branch of the Minimax algorithm, because it saw a really good move of queen takes pawn, and it thinks it just wins that pawn, but it doesn't. It loses the queen in that line. And there are ways you could solve that kind of problem. Like you could do a quiescent search, which essentially just increasing the depth up until you just continue searching through all of the captures and continue playing all the captures, keep increasing the depth until the position is quiet, there's no more captures, and then you can then evaluate and it's safe. But because of time constraints, it won't be possible to reach the depths I'd need to be able to feasibly reach to actually do a quiescent search. I can only really reach about up to depth 4 within a reasonable amount of time, so I can deliver the solution to the end users within a reasonable amount of time. So I haven't done a quiescent search because it would be extremely slow trying to increase past depth 4. So what I've instead done is just made it play a bit safer. So if it's a capture and that square is defended by another piece, I'm just assuming that piece is lost. I can't run it. I can't run this for non-capture, like regular moves as well. If the last move in a sequence is, say, moving a piece to a square where it is being attacked, then obviously that and it's not defending it, then obviously that's bad as well, and you'd want to search through that as well. But again, similar reasons, time constraints, running this for all of that would not be feasible. But this is a massive improvement in the playing strength of the AI implementing this, just letting it assume it loses the the piece essentially, which was my solution to that. Okay, and then here we get the p-square total, which is white score minus black score, because white score, positive scores favour white, and negative is black. So, and then I sum the materials, which is just getting the difference. So in here it does do the white score minus the black one, which is just summing all of the values of both sides of pieces. And then I just sum those to get the overall total, the overall evaluation of the position, and I return it. Sum material is just looping through the board. If it's a piece, get its value, add it onto the material value total, and return. And this is the queen, getting the p-square tables of it, getting the valid moves of the queen, which is moving similar to a rook and similar to a bishop. So just combining those, return the moves, get the p-square tables. So the rook here, this is getting its, it has moved here as needed for castling. You need to know that. Get its p-square table, flip it for black, and then add itself to a list here. And then this is just getting the valid moves, getting and setting the has moved, and getting the p-square tables. So essentially here, this file, start screens, this is getting all the choices from the user. So I get the constants imported here. Yes, and then I'm creating this screen here by specified screen width and screen height, which are my constants. This double AI mechanism here is just playing the AI against itself for testing purposes. Here, so I've got a create image method, so I'm just creating the play button, or the white pawn, black pawn, yes, no, the difficulty buttons, and I'm creating them, and these are the dimensions of the buttons that they'll be. And that's the font I'll be using, and then we've got the button images here, which then this is this is where they'll be, that the image will be drawn to the screen, the Y and the X, and this is the results that the user inputs, the error choice, depth, and color choice. Just the caption of chess here, and then I just do the first run, getting has quit, because if I click the X button then we leave. So this is running the play screen, and then once that's done we would leave this method. So draw text here is like a helper method. Create the font object, and then blitz the text to the screen at an X Y with that font. And then create image here is just loading an image at that file path, and then scaling it and returning. So then create button here is just getting so the index here is specified, and I just go through the button images list. At that index is then the button, and I get its location. I blit it to the screen at that location. I get its rect, and then I set the X and Y such that I can click the button. And then this is the run screen method. It's like ran recursively for each choice of the player, for each start screen that I do here. So let's create a clock object here, FPS 60. I fill the screen with grey initially. Depending on what screen it is, I draw these respective texts on chess. Would you like to play an AI? Which difficulty would you like? And what colour would you like to play as? So then, yes, I create the button 1, and then if there is a button 2 on the screen that it is, then I create that, and similarly button 3, button 4, which is only the case on the difficulty screen, so it would be both of them so I don't need to specifically check IDX4. And then yes, I update the display with all of those texts and buttons drawn on, and then for that appropriate screen. And if I quit here, then I return true as having quit. If it's a mouse button down, I get where you clicked. If you clicked a button 1, then if it's the play screen, I output that I clicked that one, and then I can run the AI choice screen, and then I can return false here, because then I can leave, and false is has quit, so I haven't quit. So yeah, you do return false there to leave. To what called it, and then essentially AI choice here. If you clicked button 1, that's yes, so I append that to the results as true. And then I can run the difficulty screen now. All these indexes being of the buttons that I create for the difficulty. And similarly here, yeah, return false. So I can leave this once I've finished selecting. And then yes, so color choice is true, then that would be the white pawn button. So I append white on here, and then I quit out. And then if it's the depth choice, I'll be clicking button 1, which is novice, and then I'd be running the color choice screen and returning false. And if I'm clicking the second button, and if it's AI choice, then that would be false on playing an AI. And then so none would be the difficulty. And then here I'd then just be running the color choice screen and returning false. And then if it's the color choice, that would be clicking the black button, which is that. If it's the depth choice, I'll be clicking the casual depth 2 button, and then I'll be running color choice. And then here this will be the difficulty screen, so I'd be clicking that's intermediate and that's advanced, and then I'd be running the color choice screen with those indexes, and adding those depths here into the results, and then ticking FPS, and I leave start screens. So this is the user interface file, so I'm importing all the different files here and everything I need from the constants file. So this is the user interface. I have the screen passed in because I've already created it with the start screens. Yes, so I get the board, get the manage players, clock object, and a couple of fonts to find. So then yes, so run get images. I'm getting all the images that I need here, and then draw image is just a helper method for splitting an image to the screen at an XY. Draw text, creating a font object, splitting it to a screen at an XY. Check for flipboard is just if it's necessary to flip the board, because you might be playing an AI and you don't need to flip the board against an AI. So then yeah, if you're not playing an AI and it's black, then you will need to flip the board for the duration of their turn. And if it's true and black, then you will need to flip the board, because the default is for white, so you'll need to flip it for black. So then here, this is the draw board method. So I check for flipboard as appropriate. I fill it with brown. I loop through all the ranks, and then the columns mod 2 with the row mod 2 here. That's because it needs to be alternating. So I'd only do it for every other square. So then yeah, that's why I go up steps of 2 here up to 8. And then yeah, so I will then draw the rectangle, which is the square for the chessboard. So I draw it onto the screen white because I filled it with brown, so I just draw white squares on it, alternating, so I don't need to draw brown squares. And then I draw it at the position col times square size, rho times square size, because that will be where on the screen you need to draw it, and then with dimensions, square size. So then I draw the rectangle at the bottom of the screen here. Once the board has been drawn, you want the rectangle for the buttons to go on resigning and drawing. So I draw that onto the screen. I draw all the pieces, and then I draw all the buttons, update the display, and check to see if I need to flip the board back. Draw pieces, so I'm looping through the board here. If there's a piece there, I loop through the piece images, and then I loop through each. For that index, I then loop through here, and then if str of piece, because the object might be different, but you only care about whether it is of type, like say white bishop, but you don't care because you might have multiple if you promoted a pawn to a bishop. So if you're checking if they're equal here, and setting that as the piece index, and then you're blitting that specific piece image at piece index to the screen, and then draw buttons here is just drawing the resign and draw buttons which are at these indexes here. So you want to blit those to the screen at these positions. So create the draw window. So if I click the draw button, I need to have a window where I can accept and reject the draw. So I draw that rectangle onto the screen, and the buttons that I need on it, with some text asking if it's a draw, and then just destroy draw window is just redrawing the board, which then won't have the draw window on it. Play move, so that will just be drawing the board with the for the other player, and updating the display. Create image is just loading the image at a file path, scaling it, and if it's a button, adding onto button images and returning. Otherwise, just return the image. So check for invert ranks in files is just if it's black, then you can do 7 minus to just find so to just find where you need to flip the to the row and column, because since it's oriented for white, then the user would be clicking where, like you'd need to translate that user click into where you're trying to move the piece to, like if it's, because it's oriented for white, so you need to do 7 minus for row and col. And then get images. So I'm looping through the board here. If there's a piece there, then that's the notation, the piece color, plus its notation. And then I've got that as the name of the images, for like ease of implementation. So I've got that here, and then I scale them and add that to the piece images with a little offset subtracted here, so it's not taking up the entire square. And then I load in the button images that I need. And then yes, so I create the square highlight image here as well, and I return. So get promote button click. All of the indexes are here, just initially defined. So I'll loop through the piece images, and if it's a queen and it's of your piece color, then that's the queen index, that's where the rook is, that's where the bishop is, that's where the knight is. So I get all those appropriate images. I draw the rectangle for the prompt for promoting a pawn, and I set the coordinates that I want those buttons to be drawn at with the same y. I draw all those images to the screen. I ask what piece you would like to promote to. I get the rects so I can click those buttons, and then I get the Pygame events. If it's a mouse button down, get its position. If you click the queen button, it's a queen, otherwise rook, knight, and bishop. And I tick clock by FPS. And then this is the get player move. So I'm using selected squares here to keep track of what squares the user has clicked on. So I get the images that I'll need here for this method, and I get the accept, reject, draw, resign, draw buttons that I will need. And draw window active is false. So I get the Pygame events here, and if it's a quit, we leave. It's essentially a resign. And if it's a mouse button down, I do div by square size of where you click to get the row and the column, because obviously you can't have a decimal row and column. So if it's a resign button click, then I draw the board to reset to reset the square highlight images, and then I leave as having resigned. And then if I've clicked on accept draw, or on where it is, and the draw window is active, then I can redraw the board as removing that draw window and return this as having drawn. And then if I clicked reject draw and the window is active, you want to destroy the draw window, redraw the board, update the display, and the window active is false. So, and then if you've clicked the draw button, then you get the move counter and draw by threefold, because both of those, for 50 move rule, you need to claim it along with threefold. You need to claim the draw for it to be a draw. And if it's a draw by threefold and you've clicked the draw button, then draw. Yes, and then you'll redraw the board after you've clicked this draw button. It's like resetting the move. If you've already clicked a piece, then you'll get rid of those grey dots and get rid of your selection as well, clicking the button. So then, yeah, if it's greater than or equal to 100, because 50 moves by each player, and you click the draw button, then you can leave. And then, yeah, if AI is false, then I can draw the board in the other orientation, create the draw window, update the display. So here, if I am playing against an AI, so yeah, I will need to flip the board here once because if I have the draw prompt, then it needs to be flipped to the other player's orientation, then I need to flip it back. So I get the previous move score that we evaluated in the last AI move that it played, which it knows it can achieve. So then, if the AI is losing, then it will draw. Otherwise, it won't draw. So then here, if I haven't yet clicked on a piece, and it's within valid bounds, and the draw window is not active, then I check to see if I need to invert the ranks and files here for row and column. And if if there's a piece there and it's of your type, then I add it to selected squares, and I specified that you've clicked there. I get its valid moves, and if it's a valid in check move, then I add on the square highlights, the grey circles onto the square, and I check to see if I need to invert the ranks and files here, because I may need to. And then if it's not, if there's a piece there at the final rank final file here, then that's the target piece. So I can't draw the grey circle on top of that target piece because it would cover it. So I want to draw the circle and then draw the piece on top of it, which is why I needed to get the piece images for this method. So I then draw that. I draw the square highlight here out of this position, and then I search here, and I find the target piece, and then I can draw that target piece onto the screen on top of that, on top of the grey dot. Yeah, and then otherwise you can just draw the circle because there's no piece there to capture. Draw it as normal. Highlight x times square size, and then update the display. And then if it's false, then if it's within valid bounds, invert row and col if necessary. Yeah, and you can redraw the board here, which removes the square highlights. And then yeah, you can add the row and column. So you've already had a valid click. So this will be the move, the full move in selected squares here. So yeah, if it's not none, so if there's a piece there and if it's of your own type, then it's obviously invalid. So empty out selected squares. If you just clicked on the same square, again empty it out. Otherwise, then I return this move choice, and then I can properly validate it in my move validation methods, and then I can take the clock by FPS.